This section describes each part of the pneumatic system and its controls. Most of the valves represented on the pneumatic panel are electrically controlled and pneumatically operated. This means that moving a switch to on only arms a valve to open. Once armed, the valve must have air pressure for it to open. The current example shows valve positions on the schematic that match the corresponding switch positions on the pneumatic control panel. Because switches merely arm valves to open, some subsequent examples will show valve positions on the schematic that do not match the corresponding switch positions on the pneumatic control panel. Closing the isolation valve permits isolation of the left and right sides of the pneumatic duct. Notice that with the isolation valve closed, the center duct leading from the APU and to the water tank is part of the left side of the pneumatic system. The normal in-flight condition is for the isolation valve to be closed. Details are covered later when we discuss settings of the isolation valve switch. The pneumatic system powers the engine starter. The start valve is opened, and air from either the APU or an external source provides air pressure for engine start. A cross-bleed start of one engine by the other is also possible. The engine start valve is electrically controlled from the battery bus. It requires a certain level of pneumatic pressure to open it and keep it open. The electric signal merely enables it to open. Engine bleed air flows through the engine bleed valve into the pneumatic manifold. Engine bleed air valves are used to isolate engine bleed air from the pneumatic manifold. The engine bleed air valves are electrically controlled and pneumatically operated. The pre-cooler is a heat exchanger that cools the engine bleed air. Cool engine fan air is supplied to the pre-cooler and then returned to the engine, where it is dumped overboard.